And we're live. Hi, Verge.
Hi, Mark. How's it going?
Doing all right.
Good.
I do want you to know I successfully set my ringtone last night to that 10-second montage someone put together of you saying, "Hi, Mark."
Hi, Mark. Hi, Mark. Hi, Mark. Hi, Mark. I want a montage of my hair. It's like getting so long. Oh my gosh, the watch parties have multiplied.
We
Wow.
got popcorn across the USA. A slightly lesser known John Mellencamp song. All right, I'm Mark Corelli from Ryan High School. And
Verge Cornelius, Lafayette High School, Oxford, Mississippi.
That's us right there.
That's us. And a lot of watch parties. I love these transitions today. Yeah.
All right. So the calendar keeps getting shorter. It's the end of the year thing going on. 3 more this week. We'll do some exam prep and send off. Hopefully we'll get a lot more information about that to you tomorrow and Friday. But there will be a mock exam, at least 1, maybe 2 in there, I think, right, Verge?
Yeah, for next week. That's exactly right. So that's I'm excited for that.
For those of you watching
the structure.
And for those of you watching, you all realize these QR codes that appear on each slide are different. This is the one that goes to our calendar. So if you want to see where we've been, because all of these are back on the AB Calculus channel in the advanced placement or playlist, the AB Calculus playlist in the advanced placement channel. We changed this slide up a little bit today. I still have our information about that May 12th exam that's approaching rather rapidly. And then if you look up YouTube, if you can either just search AP 2020 exam walkthrough, it's on the advanced placement channel. There's a slideshow PDF, or you can wait for the next slide and use these 2 QR codes to get to each of these. This QR code or that bit.ly will take you to the YouTube video. It's a 4-minute video that kind of walks you through the exam process. And there's a shortcut in the Dropbox. In the Dropbox, along with our document today, there are 2 HTML shortcuts. One goes to this and one goes to the testing guide. And again, this QR code will take you to that. I am going to show you what that looks like real quick. We are not going to read it to you. It's a pretty lengthy document.
Yeah, I would encourage you to kind
of. But scroll through, see what's there. There's a lot of information. There are some hot links. There is you can actually practice uploading now. It says May 4th, but it's live now and the directions are in here. So encourage you to take your time and look through that before continuing the video or after.
Yeah, I would encourage you to do that upload practice both from your phone and then also from your laptop. Try it on different devices and see what the interface looks like.
Exactly. Great advice. Yeah. And you can, it says you type in practice as your code or something, but you can do it as many times as you want. So.
Yep, definitely.
So new picture, new countdown, or count up, we hope, not down. We think we got through yesterday without anything major. Other than maybe misspelling the word response on our calendar or something like that. And this is an old picture here.
We look so young in that picture.
I'm pretty sure that's pre-2010 on that shirt. That's a 2009 shirt, I think. So.
I think that's probably like 2014 or 2015 is my guess. We couldn't figure it out this morning, but anyway.
The gray was coming, so it may have been just post-Kara. I don't know.
I had a haircut way more recently.
We all had.
Yeah.
All right, so there's introduction and banter. As we mentioned earlier this week, review days, we're not going to do a warm-up per se unless we're finishing up what we did not finish yesterday. But Verge!
We finished yesterday! Yay! I can't believe it.
There's only one bullet down there, over there, wherever it is. It's just what's today's folder, and nothing referring you back to a previous folder. So.
Yeah, that's kind of miraculous. So when we planned today, of course, we made those plans in March. We wanted to do kind of a verbal scenario or verbal STEM free response question medley. And we took 3 and adapted them from AP Central. We kind of peeled off things that are not getting tested this year and are trying to focus on things that are getting tested. And then we got a little creative, adding a few extra things in. So definitely go to that shared folder and grab that before we get started. Mark, do you have anything else before I share my screen?
Nope, I was about to ask you if you were going to grab the screen.
Yep, I'm going to grab the screen. My connectivity today has been terrible because rain. I mean, like in Mississippi, if it's raining, it's like psh, no internet. You know what I mean? So at least that's the way it is in Oxford. So if we lose each other, I apologize. But Mark has all these same problems, and he can.
Maybe we need to let you get your joke in early, just in case. I don't know.
Oh, I haven't even looked at that yet. Remind me later. Maybe when you're grabbing.
Okay.
when you're grabbing the screen later, I'll tell the joke. How about something like that? So
because of I do want to point out, because of a comment you made, I believe last week, or maybe it was 2 weeks ago now, I am wearing pink today. I don't know if it's showing up.
I wore my Wednesday pink yesterday. I just was like, I'm all confused on the flow of the clothes. Okay, so this problem is from, I don't know, 2010 maybe, or something like that.
2011.
2011. Okay, and this is verbatim the problem. It says at the beginning of 2010, and again, if I would pause if I were you, and I would work this problem right now. And now I'm going over it rather quickly. At the beginning of 2010, a landfill contained 14 tons of solid waste. So this is, because my function is W, I just read this sentence. W of 0 is equal to 1,400. Sorry, I might have said 14,000. 1,400 tons of solid waste. The increasing function W models the total amount of solid waste stored at the landfill. Planners estimate that W will satisfy the differential equation dW dt, this is looking hauntingly familiar, is equal to 1/25th W minus 300 for the next 20 years. So basically T is in between 0 and 20. W is measured in tons and T is measured in years from the start of 2010. Use the line tangent to the graph of W at T equals 0 to approximate the amount of solid waste that the landfill contains at the end of the first 3 months of 2010. In other words, at time, T equals 1/4. And I got these to where I can tear them off right now. All right, so for A, oh my gosh, I'm thinking tangent line again. Now, another way to say tangent line might be linear approximation or linearization. Can you think of anything else, Mark?
Yeah, a linear model, but yeah, you're going to see the line or the phrase linear, right?
Right.
Local linearity, but it's going to be there.
So, I mean, I'm thinking about when you open up your exam, on May 12th, a lot of times students' first reaction is, oh no, I don't know anything. And I want you to remember, you know everything. It might be that it's just phrased slightly differently. Just start doing what you know. So I see line tangent. I'm going to write the tangent line. I need two things. I need a point, which I believe I have. And I need a slope. And I've got my formula for the slope right here. What do I need to plug into W, Mark?
Well, it's W of 0. So that point is TW, so 1,400.
Yep. And those are good things to label for yourself. So 1,400 minus 300 is equal to 1,100. And then divided by 25. I think I got 44. So my equation is going to be y minus 0.
I failed to mute myself before I coughed.
I heard that.
I tried to hit the mute button. I missed. So yeah, and of course this is one I would have no problem, especially on the exam. Just leave that slope as 1,125ths, right? If you don't want to think about it. But like I tell my algebra kids, you guys can divide by 25 for days if I just say how many quarters and $11.
But then again, you guys, you do have your calculator on every single question on every single part, unlike yeah, you gave that to me a long time ago. Unlike when you were in, when this question was actually asked, it was part of the no calculator part of the exam. And by the way, these are all, we just took them straight off of AP Central. So with permission from College Board. So even though this is a question from 2011, it is available there. But Mark got me off on a tangent.
Sorry about that. Oh, cute.
But my point
Time to
being is
get
that
back
if
in
you
line.
need to
That's
if you want to check the reasonableness of your answer, because that's actually a good way to make sure you haven't made a mistake, you probably do want to get it to 44.
Right.
By the way, while Mark was sneezing or coughing or whatever he was doing, I was messing this up, so I'm fixing it for myself. It should be y minus 1400, because that's the y value, or the second coordinate, equals 44 times x minus 0. And we're supposed to be figuring this out at time t equals a fourth. So 44 times a fourth minus 0, and then plus this 1400 from the other side. And that's what Mark's talking about. Like, you can leave it like that, absolutely. Checking the reasonableness of what you've just done, though. Again, we did this, a very similar problem the other day. So you might want to go ahead and make sure that there's more solid waste in the landfill after 3 months of dumping stuff there than there was at the beginning of 2010.
And if it's going up 44, was it tons per year, then you probably should have gone up less than that in a quarter year, things like that.
Yeah, good. And you don't have to write tons, because
Right.
units were not requested here, so there's no need to write tons. I just did. So.
And this is another thing with tangent lines. You always want to make sure you read the directions really close, because notice what the first word of A was.
Use the tangent line.
And so you don't have to explicitly write the tangent line for this one. If you started throwing things together, you'd be okay. But I really like that Verge put that first line with the y minus 1400, because often it says write the equation of the tangent line, and then there's a period, and then it says use that line. So just, make sure if they ask for the line, absolutely in those cases, give it. It's safer just to give it.
Yes. Okay. Part B said to find the second derivative in terms of W, and then use the second derivative to determine whether your answer in part A is an underestimate or overestimate of the amount of solid waste that the landfill contains at time t equals 1/4. So I'm going to go ahead and calculate the second derivative here. I've got, this is part A.
Part
and
B.
Then this is part
Right.
B.
Oh, I see what you're saying.
Yeah. So let's see. dw dt is equal to, I always have to like engage with the problem. I like to write it down and then kind of get a game plan. I'm going to take the second derivative here. By the way, part of my game plan in this case, now that I look at it, is that I would probably distribute. So I get 1/25w minus 300 over 25. And I know that I'm differentiating, so that part's going to end up being 0. So second derivative is going to be 1/25. But implicit differentiation here, or chain rule, however you want to think about it, it's got to be dw dt. And then in terms of W, I can do a substitution, 1/25 times my dw dt, substituted in 1/25 times W minus 300. And then it's saying, is this estimate that we did from the tangent line an underestimate or an overestimate? They're prompting me to use this second derivative. So I really need to figure out the sign, S-I-G-N, of the second derivative. I've got 1/625 times W minus 300. So what do we think about the sign of that? Well, if W is 1400 or more, what's the sign of this expression going to be? It's always going to be positive. Exactly. So when I look at that, I realize, okay, that tells me concavity. I'm concave up there. This is my W graph that I'm trying to imagine. So my tangent line is underneath. So for t greater than or equal to 0, this is true. Therefore, tangent line is an underestimate. Am I going off screen, or
and you just scoot up a little? Yeah, scoot up a little bit.
Okay. Is that better, or?
There you go.
Okay. Okay. I know that's hauntingly familiar to what we did the other couple days. I had just changed the numbers, but it's a time where you really need to practice stuff that you already know. Continue to practice it. Don't just watch me do it. You got to continue.
Also, I want to point out, because I actually got an email yesterday from a student who said, I assume they're appreciative that we did this without their prompt. They said that they wanted to see more FRQs and how to answer them. When you're using that concavity for the underestimate, Verge absolutely had to have that for t greater than equal to 0. I think without that, I don't think you'd get full justification. So you got to be careful because you have to know it's an interval containing both the point we know and the point we're looking for.
Right. So we have to really think about concavity like over this time period, not just at that point, because like you can't just be talking about it at a point. It has to be over a certain interval.
Because the curve might flip back, right?
Mm-hmm. Right. Okay, good. Now, one thing we haven't done in a while is this part C. And when I say in a while, I think the last time we did solved a differential equation was probably on sometime last week. So maybe about a week ago. So part C says to find the particular solution, W is equal to W of t to the differential equation, dWdt equals that same thing, with initial condition W of 0 equals 1400. So this is pretty common language here. Find the particular solution. I think the last time we did something like this is with a dg dt. Sometimes we might see a dy dx, that differential expression could have lots of different variables in it. But one thing as I go to solve this differential equation, I might notice is that the only variable showing on the other side is this W. And I just think that's important to notice that I'm going to move this W minus 300 to the other side, but the dt is not going to have a t variable with it. I'm going to probably leave the 1 over 25 there. So dw divided by W minus 300 is equal to 1 over 25 dt. Separate, integrate. When you integrate here, this reminds me of what Mark said last week, defunction over function or something like that, right? So is this going to be a natural log or not?
It is. It does qualify as derivative of function over function because you're not just looking at the W, but the derivative of W minus 300 will be the derivative of W minus 0.
Right. If I had it like this, W minus 300 squared.
Yeah, no. Because now it's derivative over function squared.
Yeah, it's not the same form. So, really, if you're studying, put a lot of this stuff side by side so you can start to notice the patterns. All right. Equals now the integral of 1 over 25 dt is 1 over 25t. Now, I just want to have a shout out to my students at Lafayette. A lot of them kind of then continued going from here. They substituted in their 0, their 1400. These are my students. I was crying. What were they forgetting?
I don't know if that's a shout out or a call out. They forgot the C.
They forgot the C. Like, what in the world? Okay, I'm giving them a shout out because they're going to do so great on their exam because they're going to remember their C. Okay, but yes, I'm calling them out right now, I guess. On that first line after you anti-differentiate, substitute in 1400 for W. And what else? 0 for T. So I have the natural log of, it looks like 1100. None of those are absolute value bars. Is equal to C. So the natural log of, let's see, absolute value of W minus 300 is equal to 1 over 25t plus the natural log of 1100.
Yes.
Algebraically, got to exponentiate. I'm really done with the calculus at this point. I'm really done with the calculus like right here. But to finish it out and solve for W, which I'm being asked to do, I need to do quite a bit of algebra. So exponentiate. When you exponentiate on this right-hand side, e to the natural log of 1100 becomes 1100. And because of that plus, I can kind of bring it to the front. So I have absolute value of W minus 300 is equal to 1100 e to the 1 over 25t. So W minus 300 is equal to plus or minus that. And then finally adding 300 to both sides. And then choosing a branch. We've talked about this a lot. We have to make sure that our input of 0 yields an output of 1400. Will that happen if I choose the positive or the negative branch in this case?
Let's go positive.
Yep. Because that would be e to the 0 there. So I would have 300 plus 1100 and then times 1, and that would be my final answer. But again, just inside information like this right here, the way the AP grades differential equations, this is worth a lot of the points. And I'm not saying we're going to have a differential equation this year on our exam. I don't actually know anything about our exam. I think people have to understand that I don't have any inside information on that. But these are historically questions that show up. And not only that, they're important for you to be able to do even more so.
Right.
So anyway, done speculating. No speculating. Are you going to grab the screen, Mark?
Sure.
Okay. I'll just tell you a little joke here while you do that. And that is, have you heard of people who are afraid of negative numbers?
No, I haven't heard of people that are afraid of negative numbers.
Well, let me just tell you this. They will stop at nothing to avoid them.
Oh, that's a number line joke.
Isn't that great? That took me a little while to figure out, but I was laughing pretty hard once I figured it out.
So it is funny though. I called you out on that to Cal, but it's because I mark all of my electronics.
Marky Mark. Actually, let me. I don't know if I can do this, but
in the function bunch.
Here's my what's on my laptop right now. Of course.
Yeah, I got a silver one on mine. That's actually sporting a ring today too. That's
ooh, wow.
That was a Chicago calculus teacher that gifted me that one. So
I have my frog ring on today.
Nice.
Got it like a frog.
This is where we're at 3 weeks into these guys. Every so often we take an intermission just to check out our accessories. All right, so this is number 2. This is also adapted from AP Central, although we changed part of this one. We actually replaced D with a new part, but this is from a 2010, one of the 2010 exams. It says 2 particles move along the x-axis, and just like Verge said, you're going to open the test, you're just going to be like, oh, there's this wall of text, and you just got to read it, right? 2 particles move along the x-axis. For time between 0 and 6, the position of particle P at time t is given by the function P of t, which is this trig function. While the position of particle R at time t is given by R of t, which is this cubic polynomial. And then they ask us to do these 4 tasks, and I'm just going to scoot this up and just kind of focus on A for a second. And it says, for time 0 to 6, find all times t during which particle R is moving to the right. And believe it or not, this is actually spelled out in, I know it's spelled out in our textbook, but I think it's spelled out in the CED, that right is positive velocity or velocity greater than 0. Actually, I'm going to say, I don't like writing it that way. Is positive, and negative velocity or velocity left to 0 is movement to the left. So.
And they were careful here to say along the x-axis, and we typically think of the x-axis as a horizontal. Right? Yeah, we typically think
we always label it on the positive side. So.
Yep.
All right. And they're talking about particle R. So just like Verge did, I'm going to grab that original. I'm going to recopy it, even though it's right there.
It helps me engage with the problem. Like I feel like I'm doing something, and I think as I write it down, this is what's in my mind. Hello, you're a polynomial. When I differentiate, it's gonna be so easy, like
Where are you?
I mean, really.
No, I'm not even going to ask you where your functions are from. I just don't recognize the accent. So, but we have people watching from all over, so do not pick a locale. Okay, because whoever it is will be like, that's not our accent.
I think it's on like say yes to the dress or something.
Okay. So r prime of t. So I'm looking for how r is changing with respect to time. I want units per time. There's no units given in this problem, so it's just this obscure units per time unit. But r prime, if r's position, r prime will be my velocity, right? This will be velocity of r. And this is going to be 3t squared minus 2 times 6 is 12t plus a 9 plus a 0 that I'm not going to write, because if I write it, I'm just going to erase it anyway. So now we have r prime, and I want to know where r is moving to the right. So I want to know where this velocity or r prime is positive. So the first thing I'm going to do is, it's a continuous function. Since this polynomial is everywhere continuous, I'm going to find where the zeros are first. And a really common way of doing that, I could use quadratic formula, I could graph it on my calculator, but I'm just going to set it equals 0, factor off that common factor of 3. And then I'm looking for factors of 3 that add up to -4. So I'm going to use -3 and -1. And those are my critical numbers of r. So those are places where I could change direction, because I could change from positive to negative by not stopping at 0. See how timely that joke was, Verge? These are the place. One of these is a place where those people who fear negative numbers would stop.
Mm-hmm. But you know what? This this interval is only from 0 to 6.
Mm-hmm.
Oh, so you're never going to go past 0 anyway.
Well, but I'm talking about values of r prime or go beyond 0 and 6.
Okay.
Values of t, how bourgeois.
Okay. They say bougie these days.
I actually had an English teacher named Mr. Burjoyce, and I did not know there was another pronunciation for until I'd had him for about 9 months. So it was right near the end of the year. Somebody's like, "Why don't you?" He was like, basically like, "Is there anything you guys want to ask me for the end of the year?" So I was like, "Why don't you pronounce it bourgeois?" And I was like, "Why would you?" Because I was taking German and and English. So I'm going to put those numbers on a number line. Now, sign charts normally are not used to, we can't use a sign chart as a justification by itself for minimums and maximums, but it's a great way to investigate sign behavior, right? Mm-hmm. And so if I plug in a number like 1/2, I'm going to get a negative here, and a negative here, and a negative times a negative times 3 will be positive.
Positive, yep.
I plug in 2, I'm going to get a negative times a positive times a positive. And let's see if I just pick like 5, positive, positive, positive. Mm-hmm. So I am moving to the right. So r prime of t is greater than 0, and r is moving right. Can you still see?
Yeah.
I'm going to scoot it up a little bit. And they asked for all times. So we're 0 to 1. How about at 0? Do you know, Verge? I don't think they included it. I think they
find all times t.
0 is the beginning of our.
Yeah, I don't know. I mean,
do you like interval notation or do you like inequalities?
Like I usually use inequality. I would use interval notation in this case.
I just really mess with people.
Yeah.
Mix and match.
Like when we were doing those mean value theorem problems the other day, and we had to like talk, or no, it was intermediate value theorem problems. We had to talk about the number that was in between the other number. Obviously, you want to definitely use those inequalities there. But here we're just talking about just that single interval. Yeah, no, I would have written it like that.
Now, as far as FRQs go, because you could graph this, right? We could take a calculator, throw this in or in Desmos, and try to get and just graph it. We are grading your calculus. It did not say show reasoning. It's understood that you have to show any calculus reasoning going on behind it. If a student just answered that, they would not earn full credit, right? If they just came in with that part. So
right. There's no evidence as to how they got
even though it doesn't say show work, realize you always have to show your calculus and some of the computations and your reasoning. All right, on to part B. Find all times t during find all times t during which the two particles travel in opposite directions. So I'm going to keep it close.
Yeah.
Because I know
that's
where
all the analysis
I
you
know
need
where
for
R is moving now, right? But P,
you just have to figure
in fact,
out
I'm gonna
for P.
I'm just going to say R is going left from 1 to 3 and right on 0, 1, 3, 6. And then that's going to, I'm just bringing that from part A.
Yeah, because then you can kind of overlay it with whatever you figure out for P.
And now P prime, actually, let's go ahead and change color so we can talk about overlaying like that. I like that. So P.
By the way, Marcus,
I'm not going to recopy it now because we're at 130 and you get it right there. So P prime, go ahead.
Well, I was just going to say Mark is taking the derivative because he was given the position function. You got to read carefully. Sometimes you're given the velocity function, and if you have to answer a question about the direction, then you don't need to be starting by taking the derivative. You need to be starting by analyzing the velocity function. So I think we just launch into it right away, but realistically.
Well, and I had talked about it in A because it gave us two positions. So,
okay.
Because I had made that connection for V of R being our prime.
True.
All right, so we're looking at P prime this time. And oh my goodness. So -2 times pi over 4, -pi over 2. Oops. That left parenthesis was in the wrong spot. Okay. So now I want to see where this equals 0 because I want to see where P changes directions. That is a negative, right? That was the negative of a cofunction. So because it's not going to matter in finding the points, but obviously my work needs to be correct to earn full credit. So, and I'm just going to divide that pi over 2 off. So really what I'm looking for is when does that equal 0? And so that's going to be when pi over 4t equals 0. When pi over 4t equals pi. And I think the next one would be when pi over 4t equals 2 pi. And I think that's actually going to be outside our domain, but I'm going to investigate it.
Yeah, it is going to be.
So when t equals 0, the pi's cancel. This is a 1, multiply by 4. Yeah, and this one when I multiply by 4 over pi. 4 over pi. And that's outside our domain.
But those are all those unit circle values where the sine is equal to 0. Or if you think about the sinusoid, the graph, boom, boom, boom. Those are all those x-intercepts on that one period.
I make sound effects, boom. Yeah, and it's funny because I was actually going to do that. I was going to say, all right, so this is a negative sine wave, right? So it's doing this. I'm just kind of visualizing what it would do. So it's going to be negative here and positive here. So this is my movement right, and this is my movement left.
It's going down below the x-axis first.
So P is left. Yeah, I don't have to write all of this, but I'm doing it to organize my own work. And right on 4, 6. And now go back to the question. Always go back to the question. When are they traveling in opposite directions? So this is going left from 0 to 4, and then R is going left. It starts off going right from 0 to 1. So it's like 0 to 1, they're opposites. If I'm going to come down and do this, where's the red? So the red starts off going like this. And then, is that right?
No, 0 to 1. You got to do a teeny tiny hump.
Teeny tiny.
Yeah. I think the other way though, it's right 0 to 1. If you're trying to do R.
See, this is why I should have done this. You know what? I'm gonna do it different.
No, I like this way.
Nah, I'm gonna do this.
You're just gonna do sign chart?
I'm just gonna bring these in. Because this is the way I got it written up there. So we're going left here.
No.
Gosh. There we go.
Yes, yes, you did it right.
That was first, so I put it first. All right, so now we can look. All right, so I've got some right and left overlap at 0 to 1. They are both going left. And then from 3 to 4, from 3 to 4, the red is going right and the orange is going left. And then they're both going right after that, I think, right? Correct. So, wow, that was way harder than it should have been.
Yep.
But,
yep.
And that's why you got to take your time and read, right? You start talking about it at the same time, you're in a lot of trouble. So, all right. And then, let's see, was that C or B? Where am I now?
That was
totally lost my place.
That was B. You're on C now.
C. Okay, good. We get to start over. Kind of. Find the acceleration of particle P at time t equals 3. Is particle P speeding up, slowing down, or doing neither? Okay, so explain my reasoning. Well, how do I find acceleration, Verge?
Derivative velocity, and this is for P, so we can pull in what we got for our velocity, which was
so this is going to be P double prime, right? And so I can pull in that velocity, which I had negative. The simplified form was pi over 2.
And then sine of pi over 4t. Yep, that was the velocity.
So that was my velocity. So my acceleration, the derivative of sine is cosine. I'm going to chain out another pi over 4.
Let's see how you left a little space.
Yeah.
Oh, and he multiplied it by the pi over 2 simultaneously. Nice.
Yeah, that's the pi over 2 times pi over 4 going on. All right. And then they want this at 3. So a sub p of 3 is going to be negative pi squared over 8. I don't know why I made that C in parentheses. Cosine of 3 pi over 4. And I could stop there. That is a numeric answer.
And well, and also you can declare. Oh, they actually asked for the acceleration. Yeah. But yeah.
But I actually need to get a little bit more information anyway. Cosine of 3 pi over 4, that's a reference angle to pi over 4. So it's square root of 2 over 2, a second quadrant. So for cosine, it's negative. And the reason I'm looking at that is what's a negative times a negative?
A positive. So I know my acceleration at 3 is greater than 0.
And this has to do with the speeding up, because for speeding up, I want to compare my velocity and my acceleration. Now back here in this mess, we said at 3. At 3, this was negative. So I am just going to say that VP at 3 is less than 0. These two signs are opposite. Let's see, a sub p of 3.
Go ahead and push it up a little bit.
Have opposite signs. And thus particle P is slowing down. If they were the same sign, it would be speeding up, right?
Would you have to say at t equals 3 there, or is that like hitting the...
With those?
Probably not.
I'll go ahead and add it, but I think it's good without it because I have the 3s here.
Okay.
Also the way it was asked, I think, because it didn't say justify, it just said at time 3, is it speeding up? And if I say speeding up, then I'm answering at time 3. But
and just to
it never
talk
hurts
about,
to be more verbose, right?
Yeah, just to talk about another way that you could have seen that question asked, instead of is particle P speeding up, you might see is the speed increasing or decreasing at time t equals 3, and that's really the same question, just phrased differently.
And if you're really handy with a calculator, and this is calculator active, which this one was not in real life, and when it was given in back in 2010, but your test this year is calculator active. You can also declare speed to be the absolute value of velocity, and take the derivative of the velocity at 3 with your calculator, of the absolute value of the velocity, and then that's the derivative of speed, and you can use positive or negative out of that.
That's nice. Yep.
Yeah, so what I was saying, I could do the derivative of that, or I guess it'd be a velocity because that is the speed. And that would have turned out to be negative, but that's calculator active is when that's going to be handy. All right, there's a third particle. What?
I know, too much. This question's bougie.
Okay, there's a third particle, Q, that's moving along the y-axis perpendicular to P and Q because they're on the x-axis. The position of Q is given by this, and at time 2, Q is at 4. And Q prime, or the velocity of Q, is 6. So I'll call that dq dt. They called it little q prime, but I guess little q.
They being you, because you wrote this question.
All right. And they want to, they say, describe how the distance between particle R is changing. So particle R and particle Q. So R is down here on the axis, but I don't know where it is on the x-axis. I need to find R of 2, right? Which is going to be 2 cubed minus 6 times 2 squared. 8 and 18 is 26, minus 24, maybe. 8 and 8, yeah. 5? It feels like 5.
Okay. Yes, that's what I got. That's what I got.
And R prime, well, R prime of t is going to be, I need that because I need my dr dt, because this is a related rate problem, right? This is, I guess, I don't know I need that dr dt yet. I guess that's a case of me being a little ahead of the game. Here's R. Had red 5 on there for a second. Okay.
Red 5.
So, and then if I want to find that rate, so I can do these comparisons, that's 3t squared minus 12t plus 9, R prime at 2, and I'm just going to cheat. By cheat, I mean look at my other answer, which is negative 3. And there are 2 ways to set this up, but what kind of shape do I have here, Verge?
Right triangle.
I have a right triangle. So I can do a right triangle and do Pythagorean theorem.
That's how I did it.
Or I can use Pythagorean theorem and use distance formula, because they're the same. So,
but distance formula has that, like if you're taking the derivative with the distance formula, sometimes students get nervous with that square root.
Okay.
So, but it doesn't matter.
Nope. Easy enough to fix. Okay. So we know d squared is equal to r squared plus q squared, or r and q are those position functions. So 2d, what am I going to take the derivative with respect to?
Time, because it's asking, like, it's really a related rates question with respect to time. Oh, I love that. Yeah, it's right there for you.
So d dt.
Go ahead and push it up just a little bit. Yep. So 2 capital D dt equals 2r dr dt plus 2q dq dt. Lovely.
Thank you for narrating. That was good. Right. I am going to divide those 2's off. Just take those out. And then what I'm trying to find is how my distance is changing. So d dt is going to be r dr dt plus q dq dt, or q prime and r prime, I guess, since I took those with respect to t. And then this is just over d.
Over d, yep. Go ahead and push it up again.
Okay, we don't need the stem anymore. All right, so at time 2, lots of stuff to fill in. Well, r is 5, and r prime is negative 3. And then q is the given. That's up here on this graph. That was q was at 4, and dq dt, or q prime, was 6. And then the d is the Pythagorean theorem again, right? So it's going to be the square root of that. And r was 5.
And it looks like a negative 5 on your diagram, but It's not.
That was
Or
the,
maybe it was.
I didn't heat it up. That was where the R used to be.
Yeah, it wasn't heated up enough. Yeah.
Okay. And then that's the 5 and the 5 and the 4. Jeez.
Mm-hmm.
Now, I did, I kept saying that Verge is right. I wrote it. I did 5 and 4 on purpose because I'm trying to trap some of you thinking it's a 3, 4, 5 triangle.
I was trapped kind of this morning.
Right.
I was like, why is this not working out to be the right? Oh, because I'm looking for the hypotenuse, not a leg.
And of course, this is a good place to stop. But I can also do 24 plus negative 15 is 9, and 25 plus 16 is 41. And this is how the distance is changing. The distance is increasing because it's positive at a rate of, boom. And I could say unit, distance units per time units, but no units were given, so no units are required.
And no units, yeah, we didn't say indicate units of measure.
Right.
I really love that question.
We're at 146.
Okay. I know. If you don't mind, I'm just gonna share my screen quickly.
Yeah, go for it.
And then we'll go back to the PowerPoint because we definitely don't have time to work this today, but this we are definitely working tomorrow. So I would this before tomorrow, hopefully. In particular, some of these are very traditional questions that we have here in 3. They're very traditional questions for any Cal 1 or beginning of Cal 2 course. And realistically, again, we're not trying to predict stuff, but some of this stuff might not get asked in this way this year. I'm just saying, okay, just based on lots of factors. However, especially part C, where we have to really use a definition to explain whether or not something is continuous, I really think that appealing to definitions and theorems is going to be just as important as ever. So we are definitely going to start with this tomorrow. And in particular, see if you can really work on part C in addition to the other parts before the next lesson.
Yeah, as we start talking about studying, just to add something to that is, if you're going through, AP Classroom has some unlocked practice problems for you now, R stuff, things your teachers are providing. If you're just hunting around on AP Central, look for things that would be hard to search for, right? It's open book, open note. Look for those things like, how does this fit this theorem? Because you're not going to be able to type that into some of these online calculators, and things like just what's the derivative at 5. That's not going to be on the test, right? Because you can throw it in your calculator and you're done. So.
Mm-hmm. Right, like this one, f prime of x, you can totally, given that explicit function, you can use your calculator, you can figure that out. In fact, I'll show you how to do it tomorrow after I do it analytically, okay? So things like that.
Yeah, and again, one more time, if you want to freeze screen or come back to these in a few minutes, there's the QR code and the bit.ly for our calendar.
Mm-hmm.
Here's the exam format. I'm actually going to go ahead and scoot those curtains a little faster. There's the QR code for the testing guide. That's that PDF that College Board has provided, and the 4-minute video showing you how it works. And there's the QR code and bit.ly for our Dropbox. Again, that's down in the description. If you click a little side arrow on the mobile or where it says show more on the computer. And thanks, guys.
Thank you. We only have a few more classes left. It's getting kind of close. So I hope you're doing lots of calculus without us. Yeah, we should be a short part of calculus of your day, not the long part. Bye.
Bye,
See you
everybody.
tomorrow.